Back. It is the first quarter 2026 edition of the LINBIT community meeting. This meeting will highlight some of the development work that the LINBIT team has been working on, covering exciting topics like roadmap updates. Everybody loves those. LinStore cross-platform community edition, which I just learned, I think that's what you were talking about, Johannes, is now called LINBIT SDS for Windows, which we're very excited about. We're going to be talking about DRBD reactor configs in the GUI, and then last but certainly not least, some Ansible playbook updates and everything to help make your deployments a lot easier. Thank you so much for joining us. One quick reminder, we really created these meetings as a way to have an open discussion with our software users, our current customers, our prospective customers, anybody that's interested in learning more about LINBIT and what we do. So with that said, we appreciate any and all questions, and we'll pause to answer them after each speaker. We'll try to get to all of them. We usually do, but if there's any that come up after the fact, we will be posting this to YouTube as well. We'll also take any feedback, good or bad. Hopefully it's all good. I think we've been pretty good with our track record so far in these meetings. But that's enough for me. Let's get started, and we're gonna start with a bang here. We got Philip Reisner, our founder and CEO, the creator of DRBD, I always like to say, and he's gonna share some exciting roadmap updates to get us started. Go ahead, Phil.
Thanks, Ryan. Thanks for setting the stage.
Mhm.
Then let me share my screen. Oh, where is it? Here it is. Okay, I think it's coming through.
Yep, looks good.
Um, so as maybe you already know, we have the roadmap on our homepage, and I think you find it in resources, software roadmap. Yes, here it is. And so as a roadmap shows, it has the planning, the things that we are planning to do sometimes in the future. We have what we currently are working on and what we recently released. And maybe before I go into the items, let me share that when you are a LINBIT customer, you will also find the roadmap in the my.linbit.com portal. And there you can vote on the planned features. So right now, it seems that the balancing resources in LinStore has the most votes, and so it is the top item in the planned section here. And yeah, so this is about that LinStore becomes more clever about distributing the storage resources in the cluster. Then the site awareness. Um, yeah, this is the DVD gets a concept of different sites. So this will be a big one. Um, I'm afraid and I'm thrilled about working on this. Then better support for hard disks and so on. And then maybe let's look at a few things that were recently released. And here I want to point out that we had on Monday, we had the release of DVD 9.3.1, and this brought us this item. It was called Streaming I/O here in our roadmap. But in other words, DRBD got the ability to use so-called compound pages in the kernel, and that speeds things up when you have uh, big I/O requests. So like an write a megabyte, read a megabyte, and many of those. And in the past, DVD was very optimized for the small IOs, and now we did our homework and also optimize it for large IOs. And I got pretty good feedback. So one of our partners sent me an email and saying, "Hey, I tried this out, and it speeded it up from I think it was 1.6 gigabytes to 2 gigabytes a second." So okay, a measurable improvement. And maybe the other thing, and yeah, Johannes will be talking about LINBIT SDS for Windows. So I'm not going to talk about that. So check out the roadmap yourself. You find it on the homepage. And that is it for this part. Ryan.
Perfect. Thank you, Phil. Phil's got some more to share with us, but we're going to take a brief intermission. And in case any questions come in, um, it would be kind of funny if we had some like elevator music to go during these parts. Do, 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 do. I'm not going to keep doing that. All right. Anything in the YouTube chat? Going once, going twice. All right. If something pops up, we can circle back to it at the end of your second presentation, Phil. But next, I know you're going to share some exciting things about configuring DRBD Reactor from the LINBIT GUI. So let's jump into that.
Okay. Uh, okay. Oops, sorry. Here we go. And now I switch. Okay. So the LINBIT GUI, so maybe you already know it. So it has this dashboard, and here I'm showing a developer version, right? It's not yet there. Here it got a new item. It's called HA. Maybe it becomes high availability. Let's see. So I'm showing a developer snapshot. So everything you see today, that might change, but I'm excited about it. So we're showing it today. So um, um, and this is basically a GUI for what TBD Reactor can do for you. And so here in this example, I have three of those configurations. And if I look into this NFS one, it gives me what is behind this NFS service. And you need to read that list from top to bottom. So when this service starts, at first it executes the port block resource agent with all its arguments. Then it executes the file system resource agents. So that mounts a file system on top of DBD. That mounts a second file system. I think the cluster private is used for NFS. Let's call it metadata. That's the file system that contains the data that is exported through NFS. Then it activates the service IP address. Then it activates the NFS server itself. So that's the NFS kernel server. Then it does export FS. And last not least, it does the port unblock. So that's the start order. And if it would stop the service, it goes the other way around, right? And for me, the exciting thing is that all used to be pretty complex TOML files. I think we can look into it. This is like the TOML file looks. And instead of creating such a TOML file by hand from now on, or when this is released, you can use this graphical interface. And when you select a parameter, it knows which parameters are here valid, and it gives you all the description, and it does type checking and all those so that you don't make mistakes when you edit these things. It will also have actions like evict, so move it to another machine. Right now it's running on the machine 2 of my 3 machines. So as I said before, this is in development right now, will be released soon, or I think in early April. So this is like a preview here. Okay, that's it from the preview.
Awesome. Thank you so much, Phil. And it looks like our friend Andre, aka KVAPS, has raised his hand. I know you're in the Zoom, KVAPS, so feel free to chime in there if you have the power to
Thank you.
unmute yourself. I think you do. There you are.
We've been using last time this new feature of making read-write many volumes provisioned by Piraeus operator. And I would like to ask if this interface can be integrated with the logic of provisioning these NFS servers by Piraeus operator, or it is different one.
Um, you catch me on the left foot. I don't know. I think it's different. So,
Thank you.
Perfect. Thank you, Andre. All right. If anybody has any other questions, feel free to paste them. We can always circle back to them. But let's keep this train moving. Oh, before I do that, somebody popped in a question. Brian asks, is it on the roadmap to be able to use LinStore Gateway to share multiple NFS shares? Right now, it's limited to one.
um, I think that's not yet on the roadmap. Let me check real quick. It's not yet on the roadmap, but regarding Piraeus, I think it could go on the roadmap since Piraeus uses the user and NFS server, and that could do it. While with the kernel NFS server, we have a real limitation, and there it's not possible. So that's it from top of my head, and I will take that as a request to put it on the planned features. So I'll put it
Yes.
there after the meeting.
Yes, and that is the best part, Brian, and everybody else about contributing to the community meeting is that we can add these things to the roadmap. We got an awesome thanks with a smiley face, but also he just made a comment. It'd be nice to have an NFS share on archival resource based on HDD and another with SSD backing. So that's kind of where his head is at with that feature. So thank you for that, Brian. Much appreciated. And now we will keep it moving and address any questions as they come. Next up, we have Johannes, forgive me, Johannes Kashnazar Toma. Uh,
Very good. Very good.
thank you.
Question of Homer, yeah?
Okay, Kashnazar Toma. Okay, so I'm getting
Yes.
faster. He is a
Question of Homer.
developer. He's a developer here at LINBIT. I appreciate that, by the way. And he is going to be sharing some of what he's been working on. He's really focusing on WinDRBD, our DRBD driver for Windows, and he has some exciting updates about LINBIT SDS for Windows. So I will not take up any more of his time. Go ahead, Johannes.
Yes. Hello and welcome to my presentation about what we call LINBIT SDS for Windows. SDS, as you know, stands for software-defined storage, which let you configure and maintain storage that is defined by software. Yeah. And what we have now is, of course, the solution for the Linux, and it consists of three main components like DRBD, LinStore, and DVD Reactor. So what we had on the Windows platform up to now is the WinDRBD driver, and you had to add the remaining functionality like configuring DRBD resources or even respond to DRBD events by yourself. But now it looks like this. Looks pretty similar. The only thing that's changed is the icon. So everything that is on the available, well, almost everything that is available on the Linux platform regarding to software-defined storage is also available on the Windows platform now, especially WinDVD, the WinDVD driver. It's been around for almost 10 years now. I recall when I met Phil first to talk about this project, as he asked, we talked about this project, and I say, okay, see you in 3 years. Took a little bit longer, but I can add that it's being used in production, even in very large deployments, for almost 3 to 4 years now. So it's quite stable product. Meanwhile, yeah. Then on the other, the next component is LINSTOR for Windows. LINSTOR on the Linux side is used for some installations for up to 100 physical nodes. So it can manage really large deployments. For the Windows, on the Windows side, on Linux, there is LVM, like logical volume management, or CFS for storage backend. And on the Windows side, we currently use Microsoft Storage Spaces, which is kind of it has some RAID functionality, but not over the network, of course. But it's not as feature rich as for example, LVM. In particular, there is no possibility to resize the physical volumes, and it doesn't support snapshots. So, yeah, this is. But for basic usage, it's quite a good technology, and it's seamlessly integrated in LINSTOR for Windows. And yeah, LINSTOR is written in Java, and but you don't have to worry about the Java runtime environment, because this comes also all with the installer. And a very recent development is the DB Director with the Promoter plugin, which acts as a cluster manager. It promotes resources in response to events like, for example, if the remote node gets lost, it tries to promote the service at the local node. And this is done via OCF resource agents. And we've written several resource agents for the Windows platforms. We are using the OCF, the Open Cluster Framework API for the scripts. And there are resource agents for DVD, of course. Then you can configure a service IP, file system mounting, which is basically assigning a drive letter or a mount point. And Windows services. For Windows services, it's interesting because you can manage everything that is that runs as a Windows service already with this resource agent. And for today, I will later demo two particular use cases. One is Windows file shares, and the other one is Microsoft SQL Server. Yeah, and I wanted to add that we are currently working on a support for Hyper-V, which requires a little bit more changes. So this is an ongoing work in progress. So as I mentioned, I have several things to demo, like a cross-platform cluster with the LINSTOR GUI. And then I'll demo the DB Director, which I do from the command line, because we don't have the fancy GUI integration yet. And at the last demo will be how to set up the LINBIT STS on a new Windows machine. So let's jump into that. Okay. Yeah, so this is the normal GUI. All resources are healthy, and what you can see is that there is a platform column added to the node overview. We have, let's say, for example, a Fedora Linux, we have Ubuntu, and we have 3 Windows machines. And yeah, you can use the GUI to manage cross-platform resources. So there are several use cases for this. Why do you want to do this? For example, imagine if you have 2 Windows servers and need a third server, a third node for the quorum, then you can add a Linux box which acts as a diskless witness for quorum. Quorum is a technology to avoid split brain scenarios. And another use case would be, for example, to have the storage on the Linux nodes, highly available, of course, and have the Windows nodes export the data for Windows file shares. So, but there are probably other use cases as well. Yeah, so I think it's a cool thing. Regarding storage pools, what I'd like to show you, those are the Linux machines. They use logical volume management. And on the Windows side, we got storage spaces. So it's just used for the backing storage. Not to confuse storage spaces with storage spaces direct, which is a very expensive enterprise tool by Microsoft, which is something that allows replicate data between nodes. So this is a different technology. So let's add a resource. And I probably want to add a resource definition. I do this manually now. Community meeting. Should be possible to do this. So, and then of course I do a volume definition with, let's say, 2 gigabytes. And now I place one disk of the community meeting resource on the Linux, on a Linux node. Let's take the Ubuntu node. And we use the DVD test, which is the LVM storage pool. And then we add another resource on, let's say, Windows nodes. I take the 3 node. And here I take the thin storage spaces pool. Now it takes a little bit longer because it tries to, So, and if we go, let's say, to the Windows node, I have to add now, I'm the one who is using Windows almost exclusively via secure shell, because that's what I'm used to as a long time Linux user and Unix at the beginning. So this is a Cygwin with a SSH login, but the backing operating system is Windows, and we can see what's the community meeting status. And we see that the disk is already up to date and running. And it's what you probably would expect, but it isn't apart from configuring the storage pool. There is no difference between Linux and Windows hosts. You can manage both with the same linstore mechanisms. Like, of course, you can also use the command line. I'm not showing this now, but I think the GUI is a really good product for managing even large deployments. So, but it's probably more interesting what happens if something happens, like, for example, let me just move this, oh yeah, okay. I have several Zoom windows open. They're in the way. So again, these are Windows boxes, and we have the 1 box and the 2 box, and we have the DVD reactor CTL command, which behaves almost the same as in the as in the Linux variant of DVD reactor. So we have 2 demo resources. One is Microsoft SQL Server, which is currently running on this node, and the other one is Windows File Share, which is also running on this node. So let's take a third Linux Windows box. Where I can mount the network share. Let's say I mount it as administrator and the super secret password. Okay. And now I have a shell script. Of course, it's a bash shell script, but still it's Windows, but it's a bash shell script that just writes a file on this node, which obviously works. So let's evict 1 resource, and this is the DVD reactor test 2 resource. Sorry. Yes. Okay, what I wanted to show you is you can watch that in kind of real time. So let's evict the resource and see what happens. So as the service goes down on the 1 node, we get for a very short time, like 15 seconds or 20 seconds, the failover time, we get service interruption. But as you can see, it already started on the 2 node. This is the 2 node. This is the 1 node. Yeah, and while I was talking, it's already recovered. So let's do the same for the Microsoft SQL Server. I call this, the database is called Phil, like our CEO, Philip Freisner. And yeah, it counts, as you can see. So it's very simple SQL that increments, but if it's 42, which we know that is the answer, it stays on 42. So just demo SQL. So let's evict the Microsoft SQL service from the 1 node. And as you can see, the Microsoft SQL service is already down. The cluster IP gets demoted, the DVD gets demoted, and it's already starting up on the remote node. So it behaves as you would expect. Now, this is all nice and fine, but what you really want to cover is node lost or even data center lost. So this is the 2 node, and I will stop it by force. So I hope this was the correct one. Yes. As you can see, it doesn't do anything anymore. And what I would expect now is that it's runs, the DBT runs in a ping timeout. And as you can see on the OneNote, the services were started automatically. And it's continuing now. So failover time is about 15 or 20 seconds. I have to add that we are, for example, using PowerShell for for doing some of the configuration. And PowerShell alone takes maybe 2 or 3 seconds to boot up. So probably the failover times are better on a Linux machine, but yeah, I think 20 seconds is not that bad. Yeah, maybe we can improve it by lowering the ping timeout, but it also shouldn't be too low because then you get a flapping resource. So it should be it's a little bit tunable. So I leave this as it is, and the last thing I wanted to show you, Ryan, do we have any questions already?
Nothing that I'm seeing yet.
Okay. Okay, then I'll show this little thing. I hope this works. Does it work? Okay, yeah. On the LINBIT website, you can download an eval version. It is a full version with no limits regarding number of nodes or size of the storage resources. The only thing is you have to put your computer into the so-called test signing mode because it doesn't come with officially signed Microsoft signature. This is part of a subscription from LINBIT. So if you use it in production, we recommend that you buy a subscription and get the officially signed WinDVD driver because in test mode it's not meant for production. I mean, you can run it in production, but it's probably yeah. Then you are on your own when something happens. So okay, so let's do this. And as you would expect, yeah, it asks you if you want to run the Linster controller on the machine. You select yes when you are creating a new cluster. Then you accept the GPL. And as a last step, it extracts and it installs all the components. So it's a single installer for everything. And now this is something that pops up because it's not officially signed driver. Yeah. But apart from that, everything should work as expected. So now we are installing Linster server, which there are lots of Java archives in there. It takes a little bit longer. And finally, we go to the DVD reactor. Actually, this is wipe coded, so I used Claude to code this GUI. So that was lots of fun. Yeah, and now we get this link, and sorry about that. And now it's again a warning about official build. And now you can start to configure your cluster. Say we add this is X1, and I think the IP address is 98. I'm not 100% sure. let's see. Yeah, so we already got the node. And yeah, what is left to do is configure storage spaces and configure the resources, and of course add more nodes. Could be Linux or Windows nodes, of course. And that's all from my side. Thank you very much for listening. And yeah, I think we are having lots of fun with this new development. Actually, I had lots of fun implementing it. So yeah.
Awesome. Thank you, Johannes. And I think you having fun comes through in your presentation, so that's always good. Um, I do have a couple questions for you. Um, so the first one comes from YouTube, and it says, "So if I can use DRBD as a storage for Windows, the drivers also come with it." And then second part is, "Can I use LVM or ZFS on Windows?"
Yes, okay. This very good questions. The driver for Windows, the DVD driver called WinDVD on the Windows platform, comes with this installer. You've seen this just being installed. And regarding CFS, we know that it exists for on the Windows platform. I think it's possible to support it. For LVM, it probably we did how do you call it? Like some experiments, or let's say it's a feasibility study where we got the driver running, but the cross-kernel interfaces were missing because LVM depends on the device mapper driver in Linux. So it's possible to do this, and it's a work in progress. But it won't take 10 years, but it also won't take just 2 weeks or so to add somewhere in between.
Gotcha. That makes sense. And then you had mentioned as you were demoing just some variants in failover times between Linux and Windows. And I wanted to ask, are there any like tunable settings or maybe tweaks that people can make to affect those failover times?
Yes, also what I already mentioned is the ping timeout of DAVD. I think
Hmm.
it defaults to 5 seconds. I don't know it by heart. I think it's 5 or 10 seconds. Of course, if you lower that, but on the other hand, if you set it too low, then sometimes the resource will get moved to another node without without it being necessary.
Hmm.
So there are some tunable parameters. What you've seen the green dots becoming more. This is something that's probably not really tunable because, as I mentioned before, we are calling a PowerShell script, and the PowerShell, for some reason, takes several seconds to start up. I mean, maybe we can experiment to make that faster, but this is not something that is tunable by the user. So, yeah.
Okay, awesome. Um, take another look here, and that looks like that's it for now. If any other questions pop into your minds, this will be uploaded again to YouTube, so feel free to ask them there, and we will answer them as we can. And we will be moving on to our third and final speaker here. We have Ryan Renander, Solutions Architect, also known as Double R by me and now some others. It's starting to catch on, I think. He's my right-hand man. He's a breakfast burrito connoisseur. And most importantly, he's going to be sharing about some of the work he's been doing with LINBIT's Ansible playbooks. I'm super excited about this being on the customer-facing front because it's just going to make your deployments a lot easier. So go ahead and take it away, RR.
All right, and I assume you can see my screen.
Looks good.
Okay. All right, so yeah, pretty excited to demonstrate to the world here what I'm kind of calling our software-defined storage as code, and that's basically just deploying LinStore clusters as code with Ansible. And we'll get into how that came to be and all that here in just a second. So, kind of why did we build this? Well, we've kind of have a problem here at LINBIT, and it's kind of my problem sometimes as a solutions architect trying to bolt up our software to all these different environments. So, we target all these different OSs and like Debian and RHEL and whatever, and Proxmox and all these different platforms and OLVM, et cetera. And on top of that, there's a ton of different ways to deploy LinStore. You can have like kind of a standalone SAN that we give you all the open source components to kind of build your own HA SAN. And then we often are usually deployed as like a hyperconverged deployment alongside, something like Proxmox where the storage exists on the virtual host. And then there's a whole different array of, especially in larger clusters where you can have your storage on a small subset of your clusters, and then a bunch of like diskless clients connecting in that are still running workloads, and it gets kind of complex. But we kind of needed something to handle all of this and to repeatedly deploy our patterns, into these different environments and cross the finish line without a lot of work involved. And I will mention that Kubernetes kind of stands on its own here. And in some ways, it was the inspiration to be able to deploy outside of Kubernetes almost just as easily because, the beauty of Kubernetes is we can rely on our operator and CSI driver options and all that stuff. And, you deploy with snippets of YAML, and that becomes the way you just bring up a LinStore cluster. And it's pretty easy and effortless if you're in Kubernetes. If you're not, it was problematic. So yeah, this kind of grew over the years as some internal LINBIT automation. We've got different Ansible stacks that convert Debian host to Proxmox and then install LinStore on top of that and do all these things. And we decided to kind of and we worked on these over the years, and my kind of had a bit of a vision or dream to kind of put everything into a proper Ansible collection where it needed to go, and then release it to the public so our customers and end users can manage and deploy these clusters like just as easily as we do in our test environments and things like that. So this turned into 4 public Ansible collections, 13 custom Ansible modules in those collections. 12 of those are in the LinStore collection. That's where most of the exciting stuff is. And yeah, I mean, you have every cluster can be defined in YAML. It's idempotent. You can deploy it in one command. You can check it into version control. And it really gets those like day 0, day 1 operations up and off the ground. And this is just a quick slide about kind of some of the manual steps you might have to go through. And this is just there's more steps than this, and this is just a base, get your cluster up and running. There's no HA database. There's no storage options. It's just like kind of what you would go through. Register the nodes, run these commands. You might have tmux windows open on different machines and run this command over here and run this command over there, and it just gets there's a lot of room for error. I'd encourage everybody to go through that if you're unfamiliar with LinStore. It's nice to see how it works, but if you're deploying at scale, like if you have multiple small clusters or a giant cluster or a couple of giant clusters, that's where Ansible like really shines. And we'll get into that here. And common pitfalls, forgetting to set some options. If you go look at our LinStore users guide, you'll see just so many different options you can set and configure. It's a little daunting. Maybe you forgot to open some firewall ports. Something the Ansible playbooks would handle. There's a host name thing with Proxmox where it really needs the short host name. So if you set your LinStore with long host names, then that's a problem, but the playbooks will spot that and take care of it. And then we always encourage our customers running LinStore in production that they should make the database and LinStore controller highly available. And that's just kind of painful. You have to copy all these commands and run them in the right order. And and there's a playbook for that does it in about 5 seconds, and that can work for new clusters, and it can work for clusters that have been in production for 3 years. So some of those quality of life improvements are also in this LINBIT Ansible collection here. So yeah, this is kind of it for the most part. There's an inventory file behind the scenes with some IP addresses and host names and stuff. But the magic is in this cluster init role, which is kind of a meta role that calls a bunch of other stuff, but does it all in the right order, doesn't care what OS you have, brings in all the dependencies that we'll need, joins nodes to the cluster. If we configure the storage, we can then make the cluster database highly available as well, and then configure like the repo type and things like that. So the way this is sort of broken out, just from an overall architecture standpoint, there are 4 collections. We have a bunch of different products here at LINBIT. It gets a little confusing, and they all kind of work together. So we had to split those out into some sort of base functionality. And so limbit.common, that's pretty much just repository registration stuff. Gets you registered, gets you repo access, gets you the ability to install our packages. And then limbit.drbd, there's not a whole lot going on there. It's really just installing DRBD on any OS. It'll do some DKMS stuff and checks and whatever. And not a whole lot there except for an install role, but it's also something that needs to be called by LINSTOR or something like Reactor. It's one of those critical components there. So that's all split out into DRBD. And then similar to DRBD, we have DRBD Reactor, and that has our Reactor components in it. That may or may not be installed by a LINSTOR cluster. And then LINSTOR, the LINSTOR collection is where most of this refactoring has been going on and prepping for this public release. There's just a lot there. And the LINSTOR cluster init role will actually kind of call a bunch of sub roles in order. Like it'll set up the customer repo. It'll install the LINSTOR satellite, install LINSTOR controller, join the nodes together to form a cluster. If you have the gateway install flag set to true, it will install all of the LINSTOR gateway components, and that also pulls in Reactor under the hood. And that's actually something that's really tedious to do from scratch. It's painless if you're using one of our appliances like vSAN. It's all bundled and packaged together, and you don't need to do anything. But if you're doing this from scratch and making sure like Reactor plays well with LINSTOR and all, you got to set a bunch of options on the command line. So, again, I encourage you to do it once, but if you don't want to do it again, check out Ansible. And let's see here. So yeah, the part of the, inventory is configuration here. It is sort of the code in the SDS's code, because this is going to be different for everybody's deployment. And we've gone through and defined some preset Ansible group names, LINSTOR underscore, controllers, things like that, where you can just define a few IP address variables and some storage variables. And then there's some other groups below this that get kind of concatenated together and everything. But yeah, just put in your host information, and then you can pivot over and run the playbook and end up with a fully installed LINSTOR cluster. Yeah, and I will talk about the modules briefly, because that's sort of the other cool thing that needed to happen with the public release. Because a while back we were still wrapping some CLI commands with ansible.builtin.shell. And there's nothing wrong with that for a few things here or there, but to have a proper LINSTOR release, we needed to develop some Python modules for LINSTOR, so we can instead of running commands on the CLI, we can actually now start scripting some LINSTOR customization and configuration as code. And let me maybe just get out a full screen option for a second and bring over this. This is a local build of what some of our module documentation will look like when it's up in Ansible Galaxy and everything like that. So I can open up like the controller module, and we can scroll down and see all the properties. And the controller module is something that you might set cluster-wide properties on. So we can see right here. Let me actually make this text just a little bigger. Yeah, we can set some custom properties on the controller. Like I want to change the TCP port range instead of 7 to 8,000. We can change that and get off the default, or set a region on the LINSTOR controller, et cetera, things like that. Or the node module. This is how you would register a node in your cluster. And something that cluster init takes at the liberty of doing for you. But yeah, if you wanted to just register a new node or something like that and create a satellite node in your cluster, you can just call it from YAML. You don't have to use the command line or the GUI or something like that. And there's a really fancy example there that is actually pulled from the cluster init role. So it just joins a combined node, joins a satellite node or pure controller node, depending on what's in your inventory. So enough of that. I'll get back to the slides here for a second. Let's see here, Shift F5. Yeah, we have another example here. I just kind of went over some of that. So yeah, I guess we're ready for the live demo, and let me pivot one more time. There we go. So on the left side here, we have the Ansible inventory file. On the right side, we have the playbook that we'll be running. And then on the bottom, we have just another terminal session down here. So I'll run an Ansible command to just show you that we have 3 nodes with some IP addresses. And let's just kick off this playbook right now, and we'll let that run. So these nodes have already been updated with OS updates. We're running the latest kernel module, not kernel modules, the latest kernel, etc. They've been rebooted. It's kind of where you would want to start if you were going to set up a LINSTOR cluster for the first time. And so we'll go ahead and run the playbook on the left, and it will just go through and take a couple minutes here. And then while that's running, I'll kind of walk through the inventory on the left. So right at the top, we have our LINSTOR controllers defined, and we have 3 starting at LINSTOR 0. Our replication IP, that's usually the DRBD replication interface. It's usually separate from a management IP. For this demo, we're just using the same interface, but we always encourage a separate interface. So yeah, we defined 3 hosts, and we're doing something kind of interesting here where our LINSTOR diskful satellites group has all 3 members of the controllers. So we have, and what that does is that tells the LINSTOR roles when we go to initialize our cluster that we're going to have 3 combined LINSTOR nodes, and it's really simple. They're combined because they're both a member of the controller and a satellite group, so they become combined nodes. If we had a standalone LINSTOR controller defined by itself up here, then we would have individual host entries down in the diskful satellites here. So, but we're not doing that. We're doing a kind of a basic 3-node combined setup, something you might see in a Proxmox cluster or something like that. Just a small typical LINSTOR deployment of 3 nodes. And to kind of walk through some of this other group info here. So yeah, we have LINSTOR diskless satellites. You might have one of those in like what I like to call the 2.5 node deployment, where you have 2 nodes with storage pools, and one of your nodes does not have any storage pools, but it still participates in quorum. You would add that as a diskless satellite. And then, of course, this is a helper group, I guess. It's LINSTOR_satellites, and it has both of the diskful and diskless satellites in it. Those are the only 2 types of satellites, but they're joined into the main group there. This is kind of a custom thing. You might want to restrict LINSTOR gateway satellites to a subset of nodes in a really large cluster, but we'll not get into that here. And then, of course, your LINSTOR cluster is entirely composed of the satellites plus controllers. So that's just another kind of default group that's in the mix there. And then I will get into this part. We're just defining a couple options for our storage pools. And since this is in the all vars section, that's going to be applied to every single host in the inventory. So the LINSTOR storage pools, this is where you can define, I want an LVM storage pool across these nodes. I want, a ZFS storage pool across these other nodes. So we're just creating an LVM thin storage pool here. We're specifying the volume group we want to call it. And it has 3 physical devices. These are my virtual drives. I'm emulating this in the VM layer here. And so what this is going to do is it's actually going to create a 3-disk stripe. And Maybe on your end you'd have some NVMe devices here or something like that. And the cool thing is you can take this LinStore storage pools. Oh, I am doing the mouse scroll. I need to use the arrow keys here. So you could take that LinStore storage pool and you could put it, um, especially in a larger cluster, like think 10 or 12 nodes or something like that. You might have different storage pools on different nodes. So you wouldn't want to apply them to every single node. So you can nest that down in here, just like these IP address variables, and define storage pools per node. And so when it comes time to do the deploy storage step here, that just all gets picked up. It all gets created, and then added to LinStore. And you just had to define it. So if you define it once, it's there. The cluster init role will take it from there. And yeah, it looks like we finished our install. Everything is good. Let me pull up a couple reference commands here, and we'll check to make sure we've got a functional cluster here. Oops, if I don't copy there we go. Okay, so we've got 3 combined nodes: LinStore 0, LinStore 1, LinStore 2. I'm going to run, oh my gosh, I can't copy and paste. My apologies. There we go. So we're going to check a mod info DRBD for version string. So we're running the latest and greatest 9.3.1, courtesy of Phil. So it's just kind of a nice check to be like, okay, we're running the right DRBD here in this cluster. And then maybe one more check here. We can see we have our stripe layout and our chunk layout for our 3-disk stripe on our thin pool. So just some cluster check stuff there. And so, yeah, I mean, you saw it with your own eyes. It took a few minutes. We have a fully functional LinStore cluster installed. One thing that we'll go ahead and do here, just to demonstrate some of the power here. So we're going to go through we did not convert the database to HA. So we're going to do that right now. And all we have to do is rerun the playbook. So we'll rerun the playbook. It'll go through all the install steps. It'll check everything, see if we have any new LinStore packages, double check our config files, all that stuff. Takes maybe about 15 seconds to run through for that. And I'll go ahead and get a bigger window there. Getting there. And yeah, now we're installing DRBD Reactor because we need it for our HA database. So it's doing that. It's creating a special resource group for the highly available LinStore controller. It's kind of handing off the operation from systemd to DRBD Reactor for this. And there we go. So yeah, that took maybe about 10 seconds once we actually got to the cluster init HA database section. And yeah, everything's okay. Nothing failed. And I should be able to run, find the right command here. One more command. We're going to run a DRBD reactor control status. And we can see that the LinStore DB is currently active on the node. Specifying the 0 in the brackets here means just run this command on the first node. So yeah, the LinStore 0 is running the LinStore controller, and it has the highly available database on it. And we can probably clear that out, and let's just give it a LinStore resource list. And there we go. Yeah, you can see that our LinStore database resource has been promoted on LinStore 0, and it's HA. So yeah, it's that easy. Let me pivot back to the presentation here. Yeah, so obviously, your playbook where you're calling these roles and your inventory might change, but our collections do not. So they're available. We use them internally. We want you to use them as well in your organization. Um, it's yeah, it's just a big quality of life improvement for anyone trying to deploy this, especially at scale. I know we're kind of going the opposite way from Windows, where we're button clicking everything and going through installers. And this is I just want some text on my screen and everything is magic and it just works. Um, yeah. So, yeah, SDS is code. You get reliable, repeatable cluster deployments from YAML. You can add your nodes and all that stuff and check it into your version control. And then, yeah, day two, feel free to drop to the CLI. I think the biggest improvement here for quality of life and people managing a lot of LinStore clusters that, are not in Kubernetes, you can drop to the CLI to manage the day to day. But if you just use these roles and playbooks to install your cluster, I think that's a big improvement. So, yeah, with that, I think I'll end it there. And this is not released yet. The goal is by the end of the month to get it, instead of just having it live on our internal GitLab, we'll actually have it up on GitHub and then get it up into Ansible Galaxy and all that stuff. So, and we'll have blog posts and some announcements and some other stuff like that. But it's working pretty well right now. I like where it is in its current state, and we just got to polish it up a little bit more, and then yeah, we'll get it out for you to test, try out.
Well, if I could just give you an awkward round of applause that everybody has to listen to, I would. But that was awesome, Ryan. Super smooth presentation and demo. And yeah, being, like I said, customer facing, I'm super excited about this to help those evals and all those pre-sales conversations that we have go way smoother. So super excited about that. We have a couple things you did. I'm just going to reiterate, Brian, you asked about if they've been released and when do we expect that. Ryan just mentioned the end of this month is the goal. Add a little bit of cushion there, but I think we'll be having it come out very, very soon. And then Brian Grant also shared in the chat. Um, Oh, shiny. He said it's a nice shiny object that you were sharing. I've done something similar with Ansible and Proxmox already, but it'd be nice to see how your playbook works and not have to maintain one myself. And I agree with you, Brian. That's what we're here for, make your life easier. And I think you got a nice little look into how it works. So hopefully that was helpful. Um, I think you've kind of touched on this a little bit, Ryan, but I know you're on the front lines with us, as salespeople and kind of talking to those newest potential people to use our software. Can you talk a little bit about how you see this just positively affecting, everybody who's trying to deploy LINBIT for the first time and maybe even compared to how things are, current state?
Yeah, I think Ansible is something that kind of became pretty popular by the end of the 2010s, and it allowed you to sort of adapt a lot of shell scripts that you already were using, and kind of outshone Puppet, for some inventory management type of stuff, and yeah, and it just became really popular. And I wish we had this like 5 or 6 years ago when LinStore was a little newer. Um, but we didn't, so we have it now. But I think for those administrators and technically minded people trying to deploy LinStore who are familiar with Ansible, I think this will be a kind of a native, easy way to just take our collections. They'll know what to do with it. We'll have all the documentation behind it on the modules and the roles and the readmes and all that stuff. So it should be pretty easy to get up to speed. And we'll have, of course, our own sanctioned examples and blog posts and things like that as well. And I think that, yeah, for those people, it'll be great. They'll be able to get up to speed and probably prefer that to a CLI install or something like that. Or maybe, some people have already wrapped some of this stuff into their own automation platforms or Ansible, as well, because we didn't have anything to offer, really. So I think that's a big bonus there for those types of people familiar with Ansible. I think the other flip side of that is, I've had to sit on some of these, and where we've actually used Ansible for evals and clients that are converting with us, especially with the larger scale deployments. We had, we're talking to people who are like, they have 100 3-node clusters and they're trying to replace vSAN, and Now you have to install LinStore 100 times in 100 instances. That's something that's easy to manage with Ansible, and especially when your nodes are the same and your storage is the same, and it's your variables are literally the same. You just have different inventory files for each cluster, and if you go through these steps on the command line, when the nodes go up, so like, yeah, we have a lot of smaller clusters out there, 3 nodes, 5 nodes. But there's also a lot of 10 plus 20 node, 50 node. I don't know. There's people out there
We've
with like
seen it
multi
all.
hundreds of nodes. You cannot just fire up tmux and fly through and install it without losing your mind or resorting to having to wrap this yourself into something like Ansible. So I'm excited to give people a way to just hook into what we provide and adapt it to their current workflows and automation and all of that. So, and for the people who are not very familiar with Ansible, then yeah, we can still we have our tech guides. We walk you through it. You can run these, commands in Bash or whatever, and just get up to speed. And then we also have our appliances, which are more turnkey. Click a few buttons, type in a few things, and then you're off to the races. So the problem was our appliances were super easy, and you maybe couldn't configure everything right out of the gate. And then to do it from scratch was really painful, and there was nothing in between. So I think Ansible is kind of a nice way to bridge that gap, where it's like if you understand it, it's just a couple text files. You too can have a working LinStore cluster that was painless to install. So
Yes, yes. LinStore clusters for everyone. You stole my bridge the gap saying there. But yeah, you're totally right. Bridges the gap from the super easy, the very difficult. I think it'll just kind of round out our offerings for everyone. So very excited about that. And as you guys saw, you saw it here first. I mean, it took what, less than 5 minutes to run through it and get a working LinStore cluster. So maybe even like less than three. So very excited for that. And take another glance here at the various chats. One more comment from Brian. He said he's looking forward to be able to use the modules and our playbooks. He has his own with a lot of shell with detection of changes sort of thing going on. So like he said earlier, it's not ideal compared to just using the actual modules provided by LINBIT. So thank you for that, Brian. We're very excited to get it in your hands as well. And with that, we're going to go ahead and cue the outro. Just wanted to thank everybody for joining. That will be it for the Q1 2026 edition of the LINBIT community meeting. We do this quarterly, so the next one should put us sometime in the early summer. Um, it's hard for me to think and count months at the same time, but in about 3 months from now. And if a question occurs to you later about one of these presentations, as we've mentioned a few times, they will be posted to YouTube. All of our past ones are also posted to YouTube if you want to check those out. So we will be monitoring the comment sections there. You can also find the LINBIT team and other software users within the LINBIT community forum. We started this, I think it was either last year or the year prior, as sort of our community support option. Our engineers hang out in there. A lot of users hang out in there as well. So if you're just kind of testing using the freely available open source software, you can always ask questions there and then come to us when you need to at the lovely sales@linbit.com or rt@linbit.com. We'll throw the personal email out there if anybody wants to say hello. Final thanks again to all of our speakers today. Lots of exciting updates. I don't know. I feel like we're starting off Q1 with a bang with these, so that's very exciting. And that'll be it until we meet again in a couple months. Check out our YouTube content, as Ryan plugged a little bit earlier unintentionally. Our blog posts, we're always coming out with new content. A lot of stuff around Kubernetes, Proxmox, some OpenStack stuff coming as well. So yeah, hope to see you guys there, and have a wonderful day, everyone. Thanks again.